Hello everyone, we are solving zero and knapsack problem. This is a very interesting problem and one of the most important problem when you are starting with dynamic programming. So let's check the input and output. So we have given four variables. One is integer n, which is representing total number of items. Then our knapsack capacity w. Then values array, which is representing the value associated with each item, and weight array, which is representing the weight of individual item. And we need to return maximum profit or value we can get by picking those items and putting them in our knapsack uh, without exceeding our capacity limit. Okay, so uh, we are going to use recursive approach for this problem. So let's just make one recursive function, static int, and let's call it solve knapsack. Okay, so int value array, weight array, int w, or let's call it capacity, and integer n. Okay, so before making any calls we need to make sure the weight of current item which we are going to put should not exceed our current capacity or maximum capacity. Okay, so for that we need to have one check, which is going to be capacity should be greater than equal to weight of our current item. Okay, so I will explain you in this case as well. So our maximum capacity of our knapsack is 4 kg, while weight of second item is 5 kg. So we can't add that item to our knapsack. So we should check that before making any calls. Okay. So in this case, I will just make one variable here as int result. So in this case, result is going to be mat.max, and there are going to be two calls. So we have option, we can either pick that item or we will just ignore it and move to the next item. So we need to check from which call we are getting maximum value, and so that is going to be our final answer. Okay, so we will make two calls. First call is going to be for when we are picking that item. So we will just add val of n minus 1 as we have picked that item. So we will add value to our total value and solve case. Okay, val weight, then capacity is going to decrease by weight of that current item as we have included it, and n is going to decrement per each call. Okay, and other parameter is going to be when we are ignoring that item. So we are just moving ahead. Okay, solve case, then val weight, capacity is going to be as it is, and n is going to change by 1. Okay, so and in the remaining cases when we can't take that item, like this case, our current weight is 5 kg while our capacity is 4 kg, so we will just ignore that item and move forward. Okay, so let's just say directly we will say solve ks while weight, capacity, and a is going to decrement by 1. Okay, so we will just return this result, and we need to put one base condition. So if our n is equal to 0, that means we are at end of the array, so we will just return 0 as we can't make any profit with 0 items. Okay, so this is it. Let's try to run this code. We are going to get TLE, but for sake of understanding we will just run it. Okay, while then weight, then capacity, and then n. Okay, so we are getting the answer for sample test cases. Let's try to submit this code. Okay, so this much cases are succeeding with this approach, but some the bigger test cases are failing due to a TLA error. So we will just optimize it using dynamic programming approach. So we are going to memorize this recursive code. For that we need to make one integer dp. So let's just declare it here, and we will initialize it here is equal to new integer. So let's say n plus 1 and w plus 1. Here we are making 2D array, but in previous example of rod cutting problem we have used only 1D array. Due to here there are two changing variables, so we need to store them with reference to those two variables. Okay, so we need to make 2D array. Our DP always depends on the number of changing variables. So here we will just store that value for the further use. Cap is equal to race, and we will just make one check here. If dp of n comma cap is not equal to null, that means we have already calculated it, so we will just return in this case dp of n cap. Okay, so now let's try to run this code. Okay, we need to make a static. Yeah, let's try to run this code now. Okay, it's running. Let's try to submit it. Yeah, and all test cases are passed now. So thank you.